make a sequence of 2 videos to talk about RC circuits for my both undergraduate and graduate level classes. And this first circuit is in DC. And what happens is, to solve the circuit, we should use the capacitors as open. And this, I put here first order, it's a first order RC circuit, because even though there are 2 capacitors, and just today in class I said RC circuits only have 1 storage element, these capacitors are in parallel, so they are added up to the equivalent capacitance of 8 millifarads here. Capacitors in parallel add up, capacitors in series behave just like resistors in parallel. But back to the circuit, what happens here is we have 160 ohms in series with a 40 ohm resistor. So this looks like a voltage divider because this 18 ohms ends up in series with these capacitors. Because the capacitors are open, there's no voltage across the 18 ohms. Instead of 1 volt, I'm going to put here 2 volts for this power supply. So I am expecting, if I simulate this in DC, what happens is that the V2 will have the voltage that is across this 160 ohms, and actually you can already see here it's 1.6 volts because there will be 400 millivolts across R1. And if you do simulate it, run DC, it finds it 1.6 volts. If I add another voltage here, it's 4. Here it's also 1.6. So the difference over R1 would be 0.4 volts. But for my graduate level class, and also for the undergraduate, we're about to start looking at what happens to the circuit over time. So I'm going to make the next video a time domain simulation. And instead of this power supply, I'm going to change to a square wave. So let's go back to build.